Dante Certification Program Level 3. In this module, we will take a deeper look at VLANs, subnets, and routing. A single VLAN is a single broadcast domain. An IP subnet is also a broadcast domain. A VLAN can therefore be described to a router as an IP subnet. A word of caution: static IP addressing two IP subnets in the same VLAN is not wise. When an IP broadcast packet is created in a VLAN, it is still mapped to the broadcast MAC address. At layer 2, a device cannot distinguish between a broadcast frame from another IP subnet. Therefore, an IP broadcast in a different IP subnet in the same VLAN will still go to devices in the other IP subnet. This is a potential security risk. So, how do we avoid this? You can simply make each VLAN its own IP subnet. What if you need to send data from one VLAN to another? Picture this scenario. There are two devices. You intend to send data from device A to device B. Suppose the switch is set up with two VLANs, a trunk port, and a router. Now, device A sends a message. This packet contains the source IP address, that is the IP address of device A, and the destination IP address, which is of device B. Encapsulated in the Ethernet frame is the source MAC address and the destination MAC address. Then, the switch adds the VLAN tag inside the frame. Now the data is going to a different subnet through the trunk port connected to routers. The router now disposes the frame header and it looks at the packet. Remember, routers are interested at layer 3. It then looks at the source IP address and at the destination IP address. It knows the destination IP address of the other subnet it's also connected to. It knows the MAC address of the final destination. It rebuilds the frame with device B as the destination MAC address. The new frame now gets tagged with the correct VLAN. The packet then leaves the switch. 8021Q tag was removed because it's an access layer switch port, and we're back to just a frame and packet that device B can read. Something important to note: destination MAC address is what changes through this process. IP address remains the same. So why are we bothered about having different sized subnets? Well, because we have a limited number of addresses, we have to use them efficiently. Suppose I have a Wi-Fi subnet here. Let's say I've got guest Wi-Fi. In that case, I can use a /25 that would give me 126 IP addresses that I can give out to people that just want to use my Wi-Fi. So here I can use 6 hosts using /29-bit subnet. In this link here, I'm basically connecting this device to this device. These are two routers connected together. There are only two nodes participating in it. Regardless, it's still a network. I can also use a /30, which gives me two hosts, two IP addresses, one for each end of the link. So the trick here is that if I'm going to build a big-scale network, I should start by using the largest network first and then work my way down to the smallest. Why do we care about building the largest network first? Why does that matter? Well, it matters if I go into someone else's IT infrastructure and start demanding that I get VLANs punched through, or I want to use a different IP subnet. It's the kind of thing that drives IT managers absolutely wild. Imagine this scenario. IT administrators and managers would have a giant spreadsheet where they have very carefully organized each IP subnet to be a nice size appropriate to the location. They've got all their IP addresses in one long line, so they're using it efficiently. They know their infrastructure and their resource limitations. So it becomes important for them to organize their static IPs and subnets well. And then you show up and demand to do it differently. This can cause them to be resistant to you and can potentially cause unpleasant dynamics between you and them One thing to remember in situations like this is that on a lot of networks you don't necessarily want to connect to the public internet, so you can be in your own set of IP subnets with your own VLANs. And as long as the router is not pointing at other subnets, you can use any scheme you like. This is totally scalable, so as long as someone administratively has got you sectioned off into your own little area, it'll all work out. It's only when you start wanting to join different networks that you don't have complete control of that you need to get involved with an administrator. So actually that conversation about what is it you really require of the IT guys in terms of access to other networks is the first question to ask. If you can express to them that you want a public internet connection, you actually only need one IP address there to bridge the public internet. It's actually quite an easy thing to do. It's a case of being fully armed and fully prepared.